to study about the third control system component, Tacho generators. Tacho generator is an electromechanical device which converts the angular displacement into an output voltage. So, what is a tacho generator? It is an electromechanical device. Electromechanical means that it is dealing with both the electrical and mechanical signals, and it is producing an output voltage. So, voltage is the electrical signal, and this output voltage, it is proportional to the shaft speed. So, speed will be the mechanical signal. So what it is basically doing, it is converting the shaft speed in a proportional way into a voltage. Okay, so you have understood its definition, that it's an electromechanical device which is producing an output voltage, and output voltage is proportional to the shaft speed. Okay, now the tacho generator, it works on the principle of induction. Okay, so tacho generator, it is working on the principle of induction motor, that whatever the induction motor it is working, the tacho generators are working on the same principle. And in this principle, according to this principle, the output voltage or the torque, it is induced in the shaft. Okay, and it is induced due to the rotation of the rotor, and we are having the shaft speed. So this shaft speed, it is inducing an output voltage in the terminals. Okay, now there are two types of tacho generators: AC tacho generators and DC tacho generators. They are classified according to the input signal. That is, either the input signal is AC, then it will be called as AC tacho generator, and if it is DC, then it is called DC tacho generator. So first let us study about the DC tacho generators. The DC tacho generators, they resembles a small motor, and this small motor, it comprises of a stator. So what are the components of the DC tacho generator? We are having this DC tacho generator, it resembles a small motor, and this small motor is having a stator with a permanent magnetic field. So it is the first part of the DC tacho generator. Second, we have the rotating armature circuit, and third, we are having a commutator and brush assembly. So there are three parts of the tacho generator. First is the stator with a permanent magnetic field. Second is the rotating armature circuit, and third is the commutator and brush assembly. So this was the construction. Now this rotor, there is a rotor in it, and the rotor of the DC tacho generators, it is connected to the shaft. So the output voltage which we are getting as an output of this DC tacho generator, it is proportional to the angular velocity of the shaft, because as we have studied that the tacho generators, they are producing an output which is proportional to the angular speed of the shaft. So similarly in DC tacho generators also, the output voltage, so output voltage is proportional to the angular velocity of the shaft. Now the polarity of this output voltage, it depends upon the direction of the rotation of the shaft, that is in which direction, either clockwise or anti-clockwise, in which direction the shaft is moving. So depending upon that, the output voltage will have that polarity. So polarity of, it is depending upon the direction of rotation of the shaft. Polarity, it depends upon direction of rotation. Now let's see the circuit for the DC tacho generator. So this is the circuit for the DC tacho generators. Now the equation for the DC tacho generator can be written as, this output voltage, it is proportional to the shaft speed. So here theta is the displacement, and theta dot, it will be equal to the shaft or the angular speed. So this output voltage, it is equal to, if we remove the proportionality sign, then we have to introduce a constant. So here we are having the constant kt, and it is proportional to d theta t by dt, that is the angular speed. So if we represent in the dot form, it will be theta dot, that is differentiation of theta. Okay, here this E, it is the output voltage, and this output voltage will be in volts. Theta is the rotor displacement, and it is given in radians. And Kt, the constant which we have introduced, is the sensitivity of the tacho generators, and this sensitivity is in volts per radians per second. Okay, now this equation, it is defining the dynamics of the DC tacho generator. Dynamics means it is giving us the relationship between the output and the input of the tacho generators. Now, what are the problems which we encounter during the use of these tacho generators? First problem is that high frequency ripple is generated in these generators. Ripple means oscillations. Okay, so oscillations of high frequency are generated by the commutator and the brush assembly. So it is our first problem. The second problem is that the maintenance of the DC tacho generator is very difficult. So these are the problems encountered while using the DC tacho generators. Now let's study the second type of tacho generators, AC tacho generator. As the DC tacho generator, we have studied that it resembles a motor. So the AC tacho generator, they also resembles an induction motor. And this induction motor is two-phase induction motor. So the AC tacho generators, they resembles. Now let's see the construction or the parts of this tacho generator. This tacho generator, it comprises of two stator windings, and these stator windings, they are arranged in space quadrature. Okay, quadrature means at 90 degrees angle with each other. Okay, and the second component is rotor, and this rotor is not conductively connected to any external circuit. That means it is not connected to any other circuit external to the generator. So we are having two stator windings and we are having one rotor. Now, suppose a sinusoidal voltage is applied to the excitation winding or the stator winding which is excited. So a sinusoidal voltage and this excitation winding is also known as the reference winding. So if we represent this sinusoidal voltage, it will be ER sine omega C T. Okay, so this is the sinusoidal voltage which is applied to the excitation winding. Now, if we draw the circuit for the AC tacho generator, it will be like This is the output winding and it is the reference winding. Here we will give the AC supply, and these are the output terminals. So at the output we are going to get the output voltage E, and this is EM, the back EMF, and it is the demodulator. Okay, so this is the rotor of the tacho generator, and when this rotor is stationary, then no EMF is induced in this output winding. Rotor is stationary means that this angular speed, that is theta dot, it is equals to 0. So when the rotor is stationary, theta dot is 0. So no EMF is induced in the output winding. And as no EMF is induced, so the output voltage will be 0. Now when this rotor it starts rotating, then EMF will be induced, and this EMF is induced in the output winding, and due to this EMF induced we will get an output voltage. So when the motor turns or rotates, a voltage at the reference frequency omega c is induced in the output winding. Okay, now the magnitude of this output voltage, it is proportional to the rotational speed. Okay, so the output of the tacho generator, that is the output voltage, it will be proportional to the rotational speed. So we can say that E, that is the output voltage, it is proportional to omega. Okay, now if we remove this proportionality sign, then we will introduce a constant here, K1 omega, and we know that this rotational speed, it can be written as d theta by dt, that is the differentiation of the angular displacement. So E will be equals to k1 d theta by dt. Okay, now if we take the Laplace transform of this equation, taking Laplace transform, we get the Laplace transform of E will be Es, the constant will be as it is, and the Laplace transform of d theta by dt will be S theta s. So if we take this Es, it is our output, and theta s, that is the angular displacement, it is our input. So if we take the ratio of the Laplace transform of the output and the Laplace transform of the input, it will become the transfer function. So it will be Es upon theta s. It will be equals to S K1. So this is the transfer function of the AC tacho generator. Now, if we change any of the direction of the shaft, that is if we move it in clockwise or anti-clockwise, then it will affect the polarity of the output voltage. Or because here we are having a AC tacho generator, that is an AC signal as an output, so it will affect the phase shift in the output voltage. So the change in the direction of the shaft. So if we change the direction of the rotation of the shaft, it will cause a 180-degree phase shift in the output voltage. So if we take that when the output voltage is in phase with the that when the output voltage it is in phase with the reference voltage, the direction of the so when the output voltage is in phase with the reference voltage, the direction of rotation is, suppose it is taken as positive, and when the output voltage is 180-degree out of phase with the reference voltage, the direction of rotation is said to be negative. So keep in mind that when the output voltage it is in same phase with the reference voltage, you have to take the direction of rotation as positive, and when the output voltage is 180-degree out of phase with the reference voltage, the direction of rotation has to be taken as negative. So this output voltage, how we can write the equation for this output of the tacho generator? Because we are every time we are changing its direction, so the output will be in the modulated form and given by the equation EMT, that is the modulated output voltage. It is equal to ET sine omega CT. Okay, so this is the output of an AC tacho generator given in a modulated form. Now, if we draw the waveform for this output voltage EMT, what it will be? So this is our modulated output voltage. These are the waveform. This is the waveform of output voltage EMT. So you can see that when they are in phase and then when they are 180 degree out of phase, the direction of rotation can be taken as positive or negative. So this EMT, it is equal to ET sine omega CT. That is a multiplication of these two signals. This is sine omega CT and this is ET. So when we are multiplying these two signals, we are getting this modulated, that is this sine wave, it is modulated or its amplitude will be changed according to this ET. Okay, you can see that its amplitude has been changed and the direction is also changed every time it is moving from positive to negative. And when we are changing the phase, that is when it is in same phase or it is either 180 degree out of phase. So in this video, we have studied about the tacho generators. What is a tacho generator? It is an electromechanical device which is producing an output voltage, and this output voltage is proportional to the shaft speed. Then we studied the types of tacho generators, AC and DC tacho generator, and then one by one we studied both the types, DC and AC tacho generators. I hope this video or this topic is clear to you. Thank you.